At T-Mobile, our critical mission is providing unparalleled 5G coverage for when connectivity is mission critical. Introducing T-Priority, America's best 5G network experience for first responders, even in times of congestion. More capacity, faster speeds, better coverage. T-Priority from T-Mobile, built for tomorrow's emergencies, ready today. Discover more at t-priority.com.
For qualifying organizations on eligible rate plans, coverage not available in some areas and may be impacted by emergencies.
This episode is brought to you by Shopify. Upgrade your business with Shopify, home of the #1 checkout on the planet. Shop Pay boosts conversions up to 50%, meaning fewer carts going abandoned and more sales going cha-ching. So if you're into growing your business, get a commerce platform that's ready to sell wherever your customers are. Visit shopify.com to upgrade your selling today.
I didn't see anything opening day or Sunday.
Yeah, but that's
No.
It's got to put the time in.
We see kind of similar patterns to what you found with some of your weather severity work, Mike, right? It was freezing temperatures and amount of snow cover that contributed to kind of predicting mallard migration, and it seems like that's still a good predictor for some of the wild birds.
I appreciate it. And this was not set up. I just need listeners to know that. Because you haven't even talked about this with me yet. Really, this is the first time we've talked about it.
Yeah.
Cool. Very cool.
Yeah.
Now it sounds set up, and it's not. It's honestly not. So.
Welcome back to the Kitchen Conversations. At the Foul Weather Podcast, we truly believe that the kitchen is the perfect place for sharing information, spending time with family and friends, and genuinely BSing about life, ducks, the science of duck migration, duck conservation, and duck hunting itself. At either home or camp, the kitchen is a place to celebrate the day and come together to learn from each other, but also a place to simply enjoy life. The Foul Weather Podcast aims to use the Kitchen Conversations as a way to bring duck science with duck science people directly to you in raw form. But we also aim to simply talk with duck people across duck country as well. Very often you're going to notice that duck science people are also duck people from across duck country. Just think about that for a second. Most of the people that work very hard to conserve duck habitat and ducks themselves are also duck hunters from across duck country USA. In this episode, we meet with Ben Luukkonen, PhD student at Michigan State. Ben is tracking mallards from the Great Lakes population using GPS backpacks. Ben's aim is to understand why the Great Lakes population is declining. He works closely with Dr. Phil Lavretsky to understand how game farm genes may be negatively affecting mallard migration to southern latitudes. Taking a break from the North American Duck Symposium, we talk ducks with Ben and Dr. Phil. We're squirreled away in a back room of the conference center. Mostly in this episode of the Kitchen Conversations, you will hear about truly groundbreaking research presented for the first time just days before during the symposium. Thanks for joining us for another episode of the Kitchen Conversations. All right, we are live. All right, I'm here tonight with Ben Luukkonen and Phil Lavretsky, and we're going to talk mallards and mallard genetics. Ben's a PhD student now at Michigan State University, and these guys are just going to correct me if I say anything wrong at any point. Phil Lavretsky is an associate professor at the University of Texas, El Paso. He's been on a ton of podcasts. You probably heard Phil's name before. One of the things that I really want to make a point of here, and we're going to talk about kind of your current positions, your backgrounds and such, but that I don't think a lot of people that are duck hunters always think about the fact that waterfowl biologists, duck professors, those folks that are into this stuff at the academic level and the state level and the federal level that are looking out for ducks are also duck hunters themselves, right? And they're in the fields and in the marshes and, on the rivers and on the lakes with you. And so let's, rather than maybe get into your current positions, Ben, why don't you just talk about kind of you as a duck hunter first, and how
how that played into what you ended up thinking about as a career and going on to grad school to work on ducks.
Sure. Yeah, I think like a lot of folks who have grown up duck hunting, I was fortunate to have a really good mentor. My dad was an avid waterfowl hunter, and so he got me into duck hunting and just hunting and fishing in general. So from as early as I can remember, I was out in the marsh duck hunting, and we also did a lot of field goose hunting in South Central Michigan, and so was always interested in ducks and what they were doing for the majority of the time that we weren't out there watching them and hunting them. And so that really, piqued my interest and ultimately led to where I am today.
Yeah, so a lot of, I kind of, all the weather severity stuff that we do on the Foul Weather podcast was literally came out of like the days of duck hunting and not knowing why I wasn't seeing ducks, and the next day I'd see ducks, and I just wanted to kind of solve that. And I think that curiosity is what gets us into it a lot. So, Phil, your story as far as waterfowl. I mean, I don't even know. Were you like a science nerd and then a duck hunter, or were you a duck hunter first?
I was a duck hunter first.
Okay. Yeah.
Yeah, surprising in Southern California. It was same situation. A lot of us in the same situation. Mentor being my dad. It'd be Southern California. We came from Russia. By the time we finally had a bit of money, that was the first thing he did, was get a shotgun, and we went out dove hunting around Salton Sea area. And then eventually at 10, I got a side-by-side double trigger, because that's what my dad grew up on. And that's what I started to hunt with. First clay shooting, and then started to duck hunt. The first duck I ever shot was this hen bufflehead that ran across the water, and that was the end of my long tenure of continuously duck hunting every second I could. I essentially just grew from there. I figured, cut my teeth there and went to University of California, Davis. Mostly it was between that or Michigan. I was going to go, and I realized I could duck hunt because I have a California license. It was just easier, so I went to Davis. That was really how I picked it.
So University of California, Davis, in case people aren't.
So it's in the Sacramento Valley, where you've got a large number of complexes. The Sac Refuge system. So there was YOLO Refuge that was 10 minutes from Davis, and Delavan, Grizzly, other places that I figured out how to hunt and got good at it, and when there were ducks. And so that's what got me. And then what got me into the scientific nerd community was just being into genetics, is watching these things and thinking that they're little pterodactyls, and maybe I could bring one back. And so I married genetics and conservation biology together, and with a system that I love to talk about. So here I am.
Yeah, very cool. Very cool. Ben, we can edit this out if you want. It's up to you, and that sounds like a bad caveat to start with, since I didn't put it in here. But you did mention hunting with your dad, and I knew your dad in Michigan, and he relatively recently passed away, unfortunately.
Yep.
And this project you two started together, because he was with the state of Michigan, and he was also adjunct at Michigan State, or did he just collaborate with people? I can't remember, as a researcher.
Yeah, he was adjunct at MSU while he was working for Michigan DNR, and then he actually retired from DNR and went to work full-time at MSU.
Okay.
Yeah.
And what I remember about your dad the most is I would give, and he was around from when I was a graduate student at Long Point and working with Scott Petrie, and we'd go to meetings, and we'd just sit back there quietly in the corner, and then he would just crush everything that I thought was going on with the world of waterfowl in one sentence.
Yeah, that guy.
And he had this quiet, calm demeanor, and that's what you have too. I feel like you're a little more diplomatic. You haven't crushed my soul yet, like your dad did. But I always really appreciated his perspective, and I feel like he brought a lot of wisdom to the flyway and to waterfowl research as well. Is there a long history of him as a hunter? Does it go back to your grandfather then?
Yeah, ultimately my grandpa was a hunter and got my dad into hunting, although my grandpa was not really a diehard waterfowl hunter. He mostly hunted deer. And so it was really my dad that kind of got into waterfowl hunting, and then got my grandpa into waterfowl hunting. But yeah, my dad wasn't just a hunting mentor. He was also, a scientific mentor, research mentor, and he never forced me into, pursuing waterfowl research. In fact, I was almost going to be an engineer because I really liked.
You'd have made more money.
That's what he said. He said, you should be an engineer. You're going to make a lot more money. And I decided, it's just not going to be rewarding.
Yeah.
Sitting behind a desk, and it's going to be a lot more rewarding to, contribute to conservation. And so, yeah.
Yeah, that's cool. So Phil's like 38, he said. I'm 49. Ben?
I'm 28.
You're 28.
We're exactly 2 decades apart.
Exactly. But a lot of the same stories. So let's get into like the research you're doing, Ben, and then how Phil's stuff contributes. So you're working with Great Lakes mallards, Ben. So we'll get into why that is. How has the Great Lake mallard population changed, kind of relative to other mallard populations, and what are I'm going with it's declined, right?
Oh,
then that's declined, and then what are some of the hypotheses for these changes? So what are those changes over time, and what are the hypotheses for that?
Sure. Yeah. So when we think about Great Lakes mallards, we're talking about mallards that nest in Michigan, Wisconsin, and Minnesota, and those birds are part of the mid-continent population, which goes from the Great Lakes all the way up to like the Yukon Territory, and it's the largest mallard population in North America. And historically, Great Lakes mallards tracked changes in abundance of mid-continent mallards, which the bulk of the mid-continent population nests in the prairie pothole and prairie parkland regions. But in the late 1990s and early 2000s, both Great Lakes mallards and the rest of the mid-continent population declined. But after that, mid-continent mallard abundance went way up, and the decline has continued in Great Lakes mallards. And while we have some ideas about why that may be, we're ultimately we're unsure, and so that's what kind of initiated this Great Lakes mallard research project. And we knew from a lot of the work that Phil and colleagues have done that there's been widespread introgression of game farm mallard genes in eastern North America, and so we're interested in is that potentially a contributing factor to this Great Lakes mallard decline?
Are there other hypotheses for decline, like landscape change and things like that you looked at investigating? And then what states are involved in this Great Lakes study?
Sure. Yeah. So a couple of the other things we maybe considered is anecdotally, a lot of the banders, agency staff who are capturing and banding mallards during the preseason period, so during the summer, notice anecdotally that there's been this increase in the number of mallards in urban areas. And the way that we, track mallard abundance primarily is through aerial surveys, where, we fly planes on fixed transects and count ducks and extrapolate that density to the whole area and estimate what the breeding population is. And so there's some concern that maybe these mallards that are using urban areas are not being very well surveyed because you can't fly a plane low and slow over big cities. So that was a concern. And then kind of a third hypothesis that we were interested in is, from banding data alone, we don't have a great handle on the rate of emigration, or the rate at which mallards that are nesting or hatched in the Great Lakes are leaving to nest in other regions. And so we were interested in, our mallards that are hatching in the Great Lakes maybe leaving to go nest in other areas like the prairie pothole region, for example. So those were kind of the main things that we were interested in addressing with this research.
Good stuff. And I'm going to now ask Phil about the kind of how your genetics work helps inform Ben's research. So some people, probably heard you on other podcasts, potentially. But maybe. If not, a little... Oh my God, I'm going to ask Phil to be brief. It's good.
I don't know how to do that.
I know. That's kind of why I commented. But
no.
How does your genetics work really help inform Ben's work? Like, what's the quick and dirty background of like the game farm mallard thing, and it's kind of eased into the Great Lakes?
So we've now basically established that the release of these domestic individuals, which are our term game farm mallard. Never, if anybody on this podcast hasn't heard the term game farm mallard, you could Google it. It kind of looks like a mallard duck, but the difference is that it was domesticated nearly 400 years ago somewhere in the UK. It was in the UK, and eventually it was brought here to North America, and release programs began in the 1920s, and they continue today. And the release of them, although we thought had no impact on wild populations, we now show that it's at landscape level impacts, where these birds are, enough of them are surviving and breeding that it is now pretty widespread. If they didn't survive, I shouldn't find their babies and thus their genes on the landscape, but they are there in mass. And so two places where these genes are being found at really high rates is on the Atlantic flyway, and in particular New Jersey, Connecticut, Massachusetts, and New York, and other places like that. But the other side, we've been seeing increasing trend in the Great Lakes birds, especially over the last 20, 30 years. And so what this was like marrying two awesome projects together. And what I'm happy to say is that I can provide some sort of baseline foundational information about every single individual's ancestry, basically doing 23andMe on ducks. And that way, that level of information can be a new covariate or trait that Ben here can ask the question, well, this bird didn't go anywhere, or this bird stayed in a city. Did it have game farm mallard genes in it? And now he can actually answer that question directly. I think that's a sum up.
That was good. That was like the shortest I've ever heard you answer a question. So that's what I was shooting for. I just kind of needle you a little there. So Ben, then what methods are you using along with then? So you catch a bird, you catch a mallard, genetically what it is from Phil's work. What methods are you using to kind of answer these key questions about potential drivers of the Great Lakes mallard population?
Yeah, the main method is when we're capturing these mallards and putting bands on them during banding operations, we're marking a subset of those birds, specifically hen mallards, with a GPS transmitter. So basically it's a lot like the GPS in your smartphone. It allows us to track the duck's movements. We're getting locations from birds about every half hour, 24 hours a day, 7 days a week. And these transmitters are sending us this data every day. And so we're able to just about track these birds' movements in real time. And so from all these birds that we're putting transmitters on, we're also taking a blood sample in partnership with Phil. Could determine, are these pure wild mallards, or are they a cross between wild and a domestic mallard? And the combination of knowing the bird's genotype and being able to track birds across the landscape allows us to determine, the influence of hybridization on mallard behaviors, like local scale movements, migration, that sort of thing.
So you're also doing, what type of mallard is genetically, how it moves on the landscape, where it likes to hang out. What about nesting metrics? Is there something from behavior or from nesting that you're looking at too?
Yeah, these transmitters really give us fine scale detailed information. So it's pretty clear when a bird starts to nest, starts to incubate eggs, because they're at a specific location. They're not moving around as much. The transmitter itself is actually not moving as much, and so we can estimate if birds decide to nest, where they decide to nest, and for how long they nest for. And so that gives us information about ultimately what their productivity is, or are they producing ducklings and contributing to sustaining the population.
It's absolutely fascinating stuff. And I'm going to give away a little nugget here. I mean, we heard Ben talk the other day, so I know the answers to this stuff already, but so it helps me lead into these questions a little bit. But given that there has been a ton of chatter on social media about these potential effects of game farm mallards on migration, and I think some of it's coming from your preliminary results. So, like, what do do you think that these game farm mallard genes in the Atlantic flyway and then moving into the Great Lakes region really have the potential to affect mallards showing up at southern latitudes? And, what might be the difference between game farm mallards and then like pure wild mallards that you've been finding by tracking with these backpacks?
Yeah, so maybe the first thing to mention is that we found a lot of hybrids. I don't know if you want to say anything about that, Phil, but
Yeah, no, it's surprising. It would birds that we sampled in 2010. It was like a 40 generally speaking for the Mississippi flyway is about 40% hybrid kind of stuff and 60% wild. And now having that fine scale resolution, looking at some of these states, I mean, heck, what was it? It was like Michigan. Some of them are really bad.
I mean, not to throw anybody on the bus, but Indiana was the worst.
Yeah, Indiana, that's right. Yeah, Indiana. I mean, some of the states had very low.
I didn't even think Indiana had ducks.
Apparently they put them there.
Apparently they put them there.
Okay. Yeah, no. So it unfortunately it's increased since the last time I widespread kind of sampled like that, and so that trend is concerning. And so, but the fact that we were able to get such a wide variety of individuals, I think, really allowed us to get some really good data. I mean, for Ben to get really awesome data to really ask the question, does the genetics potentially have consequences on migration?
Yeah, that's what was striking to me was you still had a lot of wilds, but you had that full gamut all the way down to like pure feral game farms, which I don't know where they're coming from. I don't know anybody knows exactly where they're coming from. They can't be coming from too far away, I think. But go ahead and get into those details about the differences in those those movements among those different groups.
Yeah, so tracking these mallards with transmitters, we can see, when they decide to migrate, where they go and how far they go. And immediately, as soon as we got the genetic results back from Phil, it was clear that there was a pattern. And so kind of maybe where I'll start is something to be aware of is we can not only tell, are these birds wild, are they hybrids, but we can tell, what percent of their genes are wild, what percent of the genome is comprised of wild genes. And so, it could be 100% wild, and that'd be, pure wild mallard is 50% wild. You get half your genetic information from your mom, half from your dad, so that 50% is a first generation hybrid. And so we saw birds that had less than about 60% wild genes didn't migrate whatsoever.
Didn't go anywhere.
No.
Stayed in town. Basically in town. Like, I mean,
Grandma's feeding them.
Is
pretty much.
I mean, I don't want to make generalizations. Some might have been in farm ponds or something, but it sounded like from talking to you, they just stayed in town.
Yeah, so birds that are less than 60% wild, none of those birds migrated.
Yeah.
It's wild.
For the birds that were in between, between 60% wild and 100% wild, there was a linear trend in the probability or the chances that a bird migrates. So the more domestic genes an individual has, the less likely it is to fall or winter migration.
Yeah, and that, I mean, this is where I'm and it is the fall weather podcast, so I'm like thinking about the weather too, right? So, I mean, some of that is like if it got really severe, do they at least? I'm thinking maybe you did this on mild years, but you'd think they would at least like bump down to the Ohio River Valley or Tennessee and then like come back when it's warm like a resident Canada goose. But did you see any of that type of pattern, like bouncing back and forth, more so than like I think a wild bird would just want to go to the Arkansas big woods or Mississippi or somewhere like that.
I mean, yeah, that's what we think, right? Traditionally the core wintering area for mallards was the lower Mississippi Valley, but what we find with our wild birds is they behave a lot like we would expect temperate breeding geese to behave. If the weather gets cold and we get snow cover, they might fly down to the southern Great Lakes, southern Illinois, southern Ohio, a few down in Kentucky, and Tennessee area, but even those wild birds are not making it to the deep south, and so that has implications for your listeners who are in the deep south looking for mallards that are not showing up. And then to answer your question about the birds with more domestic genes, you might expect they would have some functional response to cold weather, but they just don't.
They just don't.
Really? They just die.
They stay put, and sometimes that has lethal consequences.
Oh, really?
For them.
You had mortality from that type of behavior.
Yeah.
Wow, I didn't know that.
It's not clear if those more domestic birds just don't have the behavioral instincts to respond, or if they don't have the physiological adaptations to actually fly far enough to get to open water and food.
That's nuts. Because they all have green heads, by the way. That's what makes this really hard, because they are different. Like a full game farm and a full wild are completely different beasts. But once they start to mix and such, they start to look like each other. And they all have green heads, and so it's very hard for us to notice these differences. Go ahead, Phil.
I mean, like, I wonder what would happen if you took a husky and a wolf and you bred them a bunch of times, and then you put them out on the landscape. Like, how would they act? I mean, this is kind of like what that is, right? I mean, that's actually this is the first time I'm hearing that they're like not moving, they're not, and they're just staying put and they die. Because that was the hypothesis that we had, right? We had the hypothesis that, like, look, we're starting to see some anecdotally, like, they're not putting on fat, their wings appear, like, we're seeing differences in muscle structure, things that actually have functional physiological causes that might make them, like, they just can't go. Like, even if you push them to go, they can only go, like, I don't know, so many kilometers until they're like, I'm out of breath and I gotta eat again, but there's no food. Right, so then it's like, where do you go?
That's your like the other thing too here is for the listeners, like I work with these folks on this genetic stuff too, right? So when I say this, it's from working with Phil and other folks on this, but like there's very few of these birds in most of the populations that are less than 70% wild. They just don't exist, and this might be one of the reasons. I feel like there's some of these things that must move around a bit. So you're talking like really high end, half their genetics are game farm. So there's a bunch of them that are like 70 to 90%. They're still moving. They're just doing it less so than a full wild bird in general. They're kind of halfway between the two, right? They move, but it's kind of half-assed movement in general. Is that fair kind of assessment then?
Yeah, that's right. And one other thing I might add that is probably of interest is that the more domestic genes a mallard has, the more likely it is to use and select urban areas.
Yeah. So they're in cities.
These birds that are more on the domestic side, they don't migrate, and they're really spending a lot of time in urban areas, and so they're probably finding open water in cities, and they're probably getting supplemental feed at city parks, that sort of thing.
Bird feeders, little old ladies, bird feeders. Ducks at bird feeders in the East are a thing. So yeah.
Golf courses. I don't know if you have those. That's so. Tell the listeners if I'm right or wrong.
Dude, am I interviewing or you? No,
it's fine. Go ahead. Wait, no, this is important. Was there a proportion? Because you broke it down in these different proportions. Was there a proportion where you'd say, like, it's no longer statistically different than a pure wild mallard? Like, is there a way? Is there a proportion of ancestry where you're like, they are now acting like that wild?
Yeah, it kind of depends on what trait you're interested in, but the third generation birds are pretty close to wild. And in some respects, even the second generation are approaching that. And there's maybe a difference between what's biologically significant and what's statistically significant, but it seems like for sure those third generation hybrids are pretty close.
So by the time they backcross, what is it?
Two
generations with a wild bird.
Their kids are now just they're recapitulating biologically wild mallards.
So when we had birds in our captive study for part of our National Science Foundation grant that Phil and I worked on, when we just had them in the pens, the game farm birds were just you use the word pooping out eggs, but they don't technically poop out eggs, Phil, so we got to
understand.
when they would just lay eggs in the pen, like all year round. So it seems like reproductive wise, game farm birds from being in captivity have just totally different behavior. So you said you could actually follow these units and see when they sat on nests and when they didn't. Did you see any difference in kind of nesting behavior between those with more game farm genetics versus wild mallards?
Yeah, we sure did. So these transmitters really are detailed, provide us detailed information about nesting. And what we found is that early generational hybrids, so birds that are much more on the domestic end of the spectrum, are much less likely than wild birds to incubate a nest. They're probably laying eggs, but our data is suggesting that they're spending very little or no time actually incubating or sitting on those eggs. Because ultimately they are not hatching as many eggs as a wild mallard would.
Do they look like are they doing normal nesting behavior where they go back at least to the same spot and lay an egg, but they just don't sit on them?
There's a lot of individual variation, but it seems like a common theme that we see is, for the most part, almost all of them are in urban areas. And so during the breeding season or the nesting season, their behavior changes and they might start, they might leave the pond they spend most of their time at. They might start visiting people's landscaping, different kind of odd places away from water.
Yeah.
And so I suspect they're probably laying eggs in those locations, but they're bouncing around to many, many different ones and not spending enough time in any one spot to actually sit on those eggs, as best we can tell.
Yeah, that doesn't help a population.
No,
at least.
No, it's not really what you want to hear.
So Phil, you're collaborating with Ben, but there's other collaborations you have going on kind of to attempt to determine effects of kind of mallard genetics on migration.
Yeah.
Do you want to just take a quick second and kind of highlight, and I don't do names unless somebody's on the podcast, so just use like geographic regions that you're at. I just feel like that's fair to the other people without asking them whether they want their information.
Yeah, sure. Yeah, so we're at the same time as what we started with this project in the Great Lakes with Ben, we were fortunate to get collaborators in Tennessee and Arkansas to also start putting transmitter on their birds, and a big reason for that is that there was a very distinct genetic signature south of Tennessee and north of Tennessee, very disparate signature. You go south of Tennessee and you're in November and you're hunting one of those big woods, you have a better than 90% chance that whatever mallard you get is a pure wild mallard. You're north of Tennessee, your chances are like 50-50 at this point, and that's a huge disparate situation. We had some data that starts to suggest there might be innate breeding differences between them, and we're finding that those signatures, those Arkansas, Tennessee birds, they have a direct link to the Dakotas, the prairie pot, that southern part of the prairie pothole region, and very few of them actually went to the Great Lakes. So this is a meta population dynamic where you've got a cohort of mallards that are pure wild, still going to their natal habitat of the Mississippi alluvial valley, and then you've got birds that have been transformed to more or less stop doing that for the Great Lakes birds. So potentially some of the old timers that talked about the 80s and 90s having all those awesome Halloween mallards or something like that, those might have been those Great Lakes birds that just don't come there anymore.
Yeah, we talked about this today. There may actually be like what a quote-unquote genetically extinct portions of the population that don't do the behavior anymore because they're not genetically, I'm just use the word program to do so.
Yeah, they know. We basically transformed them to stop going to probably the Carolinas, lower Mississippi alluvial valley, those different areas. They were probably the ones that in the banding record, you could see the ones that coming out of the Mississippi, out of the Great Lakes region, they'd hit the northern part of the Mississippi alluvial valley and they go straight to the Carolina coast.
Yep.
They used to do that, and now I don't think South Carolina has any mallards anymore. So
they got some this year. They got some this year on that real cold. They pushed a few.
Had to get it real cold.
Yeah.
But that regardless of that, there's a very distinct pattern in the Mississippi flyway of what birds are feeding what regions. And they are genetically distinct as well. And so there appears to be this coding that appears to be broken down in the Great Lakes, but still has a strong connection to the prairie potholes for those southern mallards.
Yeah, this is cool stuff. And, one of the things I think listeners should realize is, we started talking about this stuff and working on it 4 or 5 years ago, but in the last 3 years, it's really picked up. So it's not like we did this stuff. I mean, that's kind of in the scientific world, that's overnight.
Really fast.
It's very fast, very, very fast. So the next iteration of this work is going to take another 3, 4, 5 years. And in future podcasts, we'll probably talk about maybe what those iterations may be. But I just need, duck hunters out there to realize that when we talk about these things as hypotheses, that it's not like by next season you're going to know what the answer is. There is some time investment and then understanding and interpreting results to get there. But I really applaud Ben and the team of all the folks that were collaborators with you on the speed at which you got this stuff done, because I feel like it's, the clock's ticking, and the better we know about this, the better off we're going to be, I think, conservation-wise for mallards. But Ben, it's gotten warmer as well, right? So the thing we've got going on, I always bring it back to, like, we are the Fall Weather Podcast. So we're going to talk about weather. So it's gotten warmer, and we've got these mallard genetics moving in at the same time. So in a scientific world, we call that confounded, in that we can't tell which one is the real driver. But I'm going to throw you out on a limb here, or try to make it like which of those do you? And it's okay to say I don't know, but which of those do you think is maybe that real driver of, like, when people aren't seeing mallards show up at southern latitudes like they used to, and in the intensity? Do you have some sense of, like, from your work, which of those might be a bigger driver, or do you feel like we can't tease those apart?
Yeah, I think that's a really good question. I think it's certainly a tough one to answer, and we don't have any definitive answers, but I can maybe provide a little educated speculation, I guess.
I like that.
Based on what we're seeing. So, it's hard to say whether it's more genetics or more, weather or climate related, but, anecdotally, we see kind of similar patterns to what you found with some of your weather severity work, Mike, right? It was freezing temperatures and amount of snow cover that contributed to predicting mallard migration, and it seems like that's still a good predictor for some of the wild birds.
I appreciate it. And this was not set up. I just need listeners to know that. Because you haven't even talked about this with me yet. Really, this is the first time we've talked about it.
Yeah.
Cool. Very cool.
Yeah.
Now it sounds set up, and it's honestly not. So, go ahead.
Yeah, so, I mean, we haven't done any quantitative analysis on that aspect, because it's not really one of the main questions we were interested in. But anecdotally, some of the wild birds are still responding to freezing temperatures and snow cover by migrating. Some of those wild birds are responding by finding open water and food within the Great Lakes region. But like we kind of talked about earlier, those hybrids that are more on the domestic end are really ultimately not responding. And so I think that if you're a hunter in the deep south, a lot of the mallards you're probably getting are coming from the prairie pothole region, because that population is, roughly 10 times the size of the Great Lakes population, or the Great Lakes population is about 1/10 of the mid-continent population. Mm-hmm. So I think that probably most of the changes in migration that southern duck hunters are experiencing is probably related to climate.
To the being warmer over. Yeah. That's interesting. I never thought of it that way. That it doesn't matter as much if the Great Lakes birds aren't moving, because there's just fewer of them. It's if the birds are actually making it from the prairies, across Iowa, Missouri, and into the deep south more so. Yeah.
Yeah, and if I could just add one caveat, it's probably pretty location dependent. So like in the Mississippi Valley, that's probably predominantly prairie pothole birds, but you talked about historical links with some of those Atlantic flyway states like South Carolina. So those historically may have been primarily Great Lakes birds. Yep. And, so those differences may kind of depend on where you are at in the South.
Yeah. Anything to add there, Phil?
No, this is great. I think the one thing to add to what you said, I mean, we're good. Like I always get overly excited, and you pull me back, and
me, like I'm the leveling factor for you. That's a scary thing.
But it only lasts about 2 seconds. This is it. Yeah, no, I mean, you're right. We've done an incredible amount in like 4 or 5 years. It's pretty ridiculous. But what it's going to take is continued monitoring, right? So it's a continued monitoring to look at those trends, to understand those trends, whether they continue, whether they all of a sudden the shoe drops, and maybe it's something else. It hasn't happened yet, but you never know. Without having that continued effort and participation of partners, state, federal, and private, getting birds for every year in and year out, we won't know. That's the whole thing. We've got a situation, and we've got to be able to monitor it. And
do you want to plug Duck DNA right now? Or?
That's where I was going.
Okay, go for it.
So yeah, so if you're a hunter and you're interested in participating, please go to www.duckdna.com. Sign up. Let your DU reps know that you wanna have this program. It's a hunter scientist citizen science project. You become the scientists out there. You get to know a little bit more about your duck. It's basically 23andMe for any of your harvested waterfowl. And so please go ahead and sign up and be a partner and let us understand what the trends of waterfowl population at the most molecular level that we can.
Yeah, it's cool stuff. I did a little bit of it this year, and if you screw your kid up like I did, it's okay. If you're a citizen scientist, I'm a scientist, and I still didn't send stuff in right to Phil. But I'm going to take this in a little bit different direction because we just did the corn episode a little bit. I'm not sure when this is going to come out, but the corn episode was a thing we did, and I think a lot about ag landscapes and how it influences birds. And we also know that bill morphology of mallards with game farm genetics is kind of different from wild birds. They're more goose-like. They're shorter, they're wider, they're taller in a bird with game farm genes. They've got less of those lamellae on the end of their bill, and their nails longer. They're more like capable. I see it as something that's like good at picking up corn. But we've also seen like combines get better and less corn on the landscape. So I've actually hypothesized that corn on the landscape actually helps out those hybrids more. And as we went into an age where we had increasing game farm genetics and less corn on the landscape, that those two things didn't really help that population out, right? So a wild mallard can actually go in a wetland and filter and eat seeds and stuff. But then if you're a hybridy thing and you don't do well at that, but you can pick corn, but that corn's decreasingly available, that could actually kind of impact the population, potentially through just obtaining nutrients. So I did put this in the notes, Phil, before we did this podcast.
Yeah, so I was like, where's this going?
Phil never read the notes.
Yeah.
Maybe Ben did. Any like general, I mean, we can just be ethical. It sounds like
that sounds like a thing.
Okay.
Yeah, seems like a reasonable hypothesis.
Yeah.
Good.
So here's the thing: if we had more waste grain on the landscape,
would you have?
Then these hybrid swarmy things might be doing better. I don't know how you'd ever test that though, but
yeah,
but the problem is can they get to it, right? So like what Ben saw is what we hypothesized based on like the change in the difference in the wing length. The fact that these things don't have enough fat stores. I mean, everything that Ben saw, we basically hypothesized just from the physiological part. Like, they're jets with no fuel, so they can't really go anywhere. If you got no cue to go anywhere, and a freak storm happens, you're still not going to go anywhere. You're still going to die. And so, if they can't get to that corn, it doesn't really matter.
Yeah, but these hybridy things, like 70 to 90% are still out there moving around. And if we've just really lost the corn available, New York down, I'm getting out of Great Lakes, so I'm going to go back to my neighborhood, but New York down the Atlantic Flyway. We used to, in the late 90s, just see tornadoes of mallards going into cornfields, and that's all but ended completely. And some of that's just population decline, but it's also just about waste grain. So whatever birds that we see are really feeding in the marsh alone, and if you've got a bill that doesn't do that, then maybe I don't know. I don't know how that's
like you said, 70 plus. What we're seeing, including what Ben was seeing, is, I mean, you hit 80+%, you more or less look and act. So they probably have already recapitulated the bill. Like those kids have the bill of a wild bird
to be able
had to
it.
get there, right?
Yeah.
Otherwise, they either have already been sorted out, purged out by natural selection because they sucked at life and did survive,
Yeah.
or whatever might have happened. But that's what we're seeing is, and that's where we're trying to get to is like, look, the cat is out of the bag, and you've got game farm genes out there, but the question is can you do anything about it? And the real question is, what is wild? And so can we figure out to what extent? So it's like, okay, if it's only 2 generations, well, can we just decrease the survival of some of these game farm releases enough where the rest of the population can just go through their natural processes, and we can maybe get that population back to a healthy state where then they can actually use the landscape appropriately, and then our populations can rebound.
Yeah, the way it seems like these things are purged off the landscape. I don't want to go here. I really don't. But like if the spigot turns off, I don't think we're at a case. I've talked about this. Like there's some evidence. Ben's study is really good, but the body of evidence for even talking about ending game farm releases, and it would probably be state by state and not federal. I think we're a long ways from it. You know, if ever. But if you shut the spigot off, the way these things are purged, it looks like they would just look like wild mallards really, really quickly. Like what continues to perpetuate this is the influx of
it's additive. It's the continuous adding. And we saw in our historical data in the 1920s where we had that bump, and then all of a sudden all 4 flyways go back to 0. You know, there's enough of that parental pool to just essentially it looks again in a decade, which is essentially 2.5 generations.
Right.
It
looks like
gone.
a wild population.
It looks like a wild population. Yeah. So that, and the only reason for that to happen is that those traits and their the genetics that links to those traits are crappy in nature,
at making
in the wild.
Yeah.
And otherwise they'd be there. It wouldn't matter.
I do like the word purged. Like nature just purges this.
That's really what does happen. You know, whether it's because the bird can't get enough calories and it's eating too much and a hawk gets it, or freak storm happens, can't fly anywhere because it's got no fuel, dies.
Yeah.
You know, that's natural selection.
So before Phil gets too far into the weeds, we're gonna wrap up with some stuff here. Really thank you guys for taking the time out of, the Duck Symposium for a few minutes to talk about this stuff and get this information out to the public. This is what I really, really like. And it's literally like duck hunters talking duck science and getting it to like these duck people across duck country. But Ben, any last, these are wide open at the end, right? Any last comments to the duck hunting community, general advice that you'd provide? Kind of your generation, since you're the young buck here, your generation to kind of make duck hunting better for all of us.
In a way, it ends where it begins.
Very insightful.
Thank you for sharing this Red Baron with us, Linda. It's so tasty, it makes me want to share something of my own. I didn't actually read the book.
Me neither.
I watched the movie last night.
I judged it by its cover.
I haven't read a book since middle school.
I'm secretly seeing 2 other book clubs.
And I can't even read.
I'm not really Gary. He just paid me to be here. Sharing Red Baron pizza can lead to more sharing.
Experience a progressive lens engineered with AI from Essilor, powered by individual measurements of your visual behavior. A lens personalized to you by an Essilor expert. Discover Verilux XR Track and enjoy instantly sharp vision in motion and seamless transitions from near to far. Find your local Essilor expert today at Essilor.com.
Yeah. I guess I'd say, we're learning a lot, but we're still collecting data. These are preliminary results, and we've got, more work to do, but hopefully if you're interested in this, you'll stay tuned, stay invested, and just think about the issue. It's something that I think duck hunters across the country should be, thinking about and interested in, because I think this really has the potential to, be important not only now, but for our children's children and their grandchildren. Think about, do we want to give them the opportunity to, have the chance to hunt wild mallards.
Yeah, do we want to keep wild mallards with us, right? Mm-hmm. I mean, that's what this comes down to. And I am the biggest, I'm kind of in the middle. I'm like, if this isn't a problem, then we just need to go down this road. But the evidence, it does
mounting.
It does keep mounting. But that's a really good comment. And if you screw with mallards in the eastern population, that's like 1 million birds. If you screw with the Great Lakes, what is the Great Lakes population relatively in that region? It's not. It's like 800.
I have to look for sure, but it's probably 5, 6, 700,000 somewhere in there.
Right. If you mess with the mid-continent population, it's only 6.1 million now, but it's been 10 or 12 million. That's my concern. Is if this is moving west and it's going to hit that. That's what really worries me. And so the reason we got to get this right now is for that. I mean, it's already hit me where I hunt in the Atlantic flyway. We see way less birds than we did in the late 90s. We had that bag limit thing and all that. But, boy, I just don't want to see it hit the mid-continent people because that's where the Mississippi flyway, they harvest more mallards than anybody else. Phil, some reflection, kind of same thing. Maybe from a Western perspective rather than a Great Lakes of, just it doesn't even have to be about the subject. But, last comments of, it can be about the subject. But last comments, the duck hunting community of kind of advice that would improve the experience for
I mean, the first thing that I would say is keep the conversation going. If you know representatives or anybody else that you want to talk to and make sure they understand the situation that's happening in the landscape, do it. Continue to have a voice, and if you don't, you don't. I mean, we all have our thoughts, and as a person who sits on a natural wetland in the middle of a desert of New Mexico, I want to see wild mallards come into my spread. Maybe that's a purist thing, but I want to know that there are wild North American mallards that have all the right stuff over eons of natural selection and evolution, and they're there, and we're having that kind of interaction. That's what I look forward to, and I hope that doesn't get spoiled.
I love that. I was just thinking about just starting some bro science myth of I hear the wild mallards taste better too. I'm going to avoid that one. So. Thank you both for joining us on the Foul Weather Podcast. I mean, keep up the great work, both of you. Really appreciate. I mean, I think hunters appreciate what all you're doing. And to our listeners, right? Remember that waterfowl biologists, they're not your enemy. So I think you quit treating them that way. They're in the marshes, in the woods, in the fields, on these lakes next to you. They're duck hunters too, from across duck country, doing their best to keep, ducks with us for today and for tomorrow. So, thanks for joining us. And I'm going to have Phil take us out on this one.
May your skies be filled and shoot straight, my friends.